Okay, we are looking at notes packet 2, part 2 on matrices. We're going to be finding determinants of 2 by 2 matrices and 3 by 3 matrices, as well as finding the inverses of 2 by 2. We won't have to find inverses of 3 by 3. The determinant of a square matrix, and it has to be a square matrix, meaning 2 by 2, 3 by 3, 4 by 4, is denoted by this symbol right here. This does not mean absolute value. If you were taking the ACTs and they gave you something like this, you would probably think it just meant to take the absolute value of all those numbers, right? Because you don't know any differently. Well, it doesn't mean that. It's completely different than the absolute value. We use this determinant for many different concepts. When we have to find the inverse of a matrix, we have to find the determinant. Later on, when you find the area of a triangle based on its vertices, which you've never done before, you can do that by using a determinant. So those are some ways we're going to be using it. We also can use inverses to solve systems, which I'm going to show you how to do that on Monday. But we have to know determinants first. How we find the determinant of a 2 by 2 matrix is this. If we're given a matrix, see, when we're given a matrix, it has brackets. When it's written like this, it means determinant. We do A times D minus B times C. So we multiply these two numbers minus, we multiply these two numbers. Okay? So when we see it like this is not saying to make all of these positives and do the absolute value. It doesn't mean that. It's asking us to find the determinant. We have to do -4 times -6 minus -5 times -2. That's what it means to find the determinant. This is 24 minus 10. That determinant is 14. You don't have to show that first part. Let's try this one without showing. What do I get when I multiply this way? 4 minus, what do I get when I multiply that way? 4 minus 6 is -2. That's the determinant. On the ACTs, there's often a problem like this, where we're asked to find out what this x is. We have to notice that this is a determinant. So on a determinant, we multiply this way, minus, and we multiply this way. If it's minus -12, it's going to become plus 12, and they're telling us the answer is supposed to be 10. To solve this, I would subtract 12. I get -2x equals -2, so therefore x would have to be 1. Okay? Not difficult. Now we're going on to finding the determinant of a 3 by 3 matrix. To do this, we have to go diagonal and diagonal. But can you see how if I go this way with the diagonal, I'm not even using these 4 numbers? They're not even being used. So to make them be used, we have to do expansion. I have to go across, and I have to use this number. I have to go across, and I have to use this number. I really have to wrap back around. But instead of wrapping back around, I can just rewrite this column and rewrite this column. To find the determinant, we rewrite the first 2 columns. We did that. We multiply across the 3 diagonals going from left to right. So I multiply these, and I get 9. Plus, I multiply these, and I get 32. Plus, I multiply these, and I get 12. Okay? Then I subtract what I get when I go backwards, just like we did up here. These were positive minus what we got here. So when I subtract, going backwards, that's going to be -12. Plus, that's going to be, what is that, 36, -36. Plus, go back this way, 8. So we multiply all of these, and we add them together after we get those products. Minus, then we have to multiply these, get those products, and we have to add them all together. So combining these, I'm going to have 41 plus 12, that's 53, minus, this is going to be negative 48 plus 8, and that's going to be negative 40. So if I have 53 plus 40, that's going to give me 93. That was pretty tough to do, wasn't it? I mean, it wasn't that difficult, but watch how we can do this on the calculator. If we have a big matrix like this to find the determinant of, we might just want to go to Matrix, second, go to Matrix, go over to Edit, Enter, and this would be a 3 by 3 matrix. I'm putting in my numbers, 3, 2, 2, negative 2, 1, 4. I'm just putting in that original matrix. Once I have everything put in, I have to quit. So I do second mode to quit. I want to do something with that matrix, so I go back to Matrix. I go over to Math. I want to do the determinant, which is the first choice. And then I have to go back to Matrix, and I have to get the matrix A. And I'm going to have to push Enter. And it tells me that that determinant is 93. Okay? Where did I find the determinant button? Do you remember? It was under Matrix and then what? Right. That's where you can find the determinant. Any questions? Now, you want to be able to decide when to use it. I would not do the calculator for this one because there are so many zeros. See, watch. If I write these columns, the first column and the second column, because there's so many zeros, when I multiply this, that's going to give me negative 10 times negative 6 is 60, plus that's going to give me 0. That's going to give me 0. Anytime I'm multiplying and I have a 0, I'm just going to get 0. Minus, if I go here, there's a 0, it's going to be 0. Here is 0. Here is 0. See how that was faster to just do without the calculator? I wouldn't want to waste time putting that in because it was so quick without it. All right, let's look on the back. Would letter C be something you would do with or without the calculator? I would do it with because it doesn't have any zeros in it. All right, we're not going to do it with, but let's go down here. Finding the inverse of a 2 by 2 matrix. Inverses are used to solve systems. When I say a system, I'm talking about this. That would be an easy system to solve, figuring out what x and y have to be to make this true. But we could also use inverses, which is what we're going to do on Monday for more complicated systems than this. Here's what the process is. First, we find the determinant of A. It cannot equal 0. The reason why is because every one of these is going to get divided by the determinant. See how it says 1 over the determinant of A times this? If the determinant of A is 0, I would be dividing by 0. It's not allowed. So you're kind of happy if the determinant is 0, because then you don't have to do the inverse. There is no inverse. You can just say no inverse. You don't have to do the problem. Here's the other thing we have to do. We're going to divide by the determinant. We have to switch these two numbers. And then we have to change the signs on these two. So it says, in other words, switch A's and D's, switch their position, and change the signs on B and D. Let's just say B and C, rather, B and C. Then divide each entry by the determinant of matrix A. First thing we have to do, find the determinant. So if I go across here, 2 minus negative 3, what's that determinant? So our determinant is 5. Now I'm going to start doing the switching to find my inverse. This is the notation we use for the inverse. So to find the inverse, I have to switch these two. So this becomes 2, this becomes 1. I have to change the signs on these two. So this is -3 and this is +1. And then so I find the determinant, change A, B, C, D as needed. And then the third thing is divide by the determinant. So our determinant was 5, so I have to divide every one of those by 5. So the inverse would be 2/5, -3/5, 1/5, and 1/5. Let's say we want to check that. Go to your calculator, go to Matrix, go over to Edit. Our original matrix was a 2 by 2 matrix. Put it in. Once you have it in, you need to quit. Now, this is a little different. We want to do inverse. This button right here, that's the inverse button. Okay? So I have to get matrix A. To get it, I go second matrix. I get my matrix A, and then I say I want the inverse. So I have to push this button right here to get the inverse. It tells me this is the inverse. My answers are in fraction form, so I can go to Math, Frac, and it'll write those as fractions. And we can see that our inverse is correct. All right, let's try another one. What's the first thing we have to find? Determinant. So I'm going to have to do -7 minus -6. What's that going to be then for the determinant? -1. So now what we have to do is switch these two, change the sign on these two, and what's the last thing I do? Divide by the determinant. So divide that by the -1. Everything gets divided by -1. That was pretty easy. We don't have any reason to check that. All right, what's going to happen on this one? What's our determinant? 0. What does that mean? No inverse. We don't have to do anything else. We like those. Let's find our determinant here. That's going to be -8 minus -6. What's our determinant? -2. You guys finish it now. You can watch up here if you're stuck. Try it on your own.
I don't know what it is.
And check your answer and see if you got it the same thing I got.
Oh,
Yeah, Bryce?
So if on that test, there was no inverse, could we put can be done? Does that matter?
No, I would still accept that. All right, guys. So you can use your calculator or you can do these by hand, whichever is going to be the fastest way for you to do.